The Brain of the Machine, Why Memory Matters. Written by Linus Sebastian, Linus Tech Tips. Hey everyone, Linus here, and today we're diving into the fascinating world of computer memory. You know, that mysterious stuff that lets your computer juggle apps, documents, and cat videos without breaking a sweat? It's more than just a component, it's the lifeline of your system's performance. It's easy to take for granted, but trust me, memory is the unsung hero of your digital life. Without it, even the most powerful CPU would be left twiddling its thumbs. Think of it like this. Your computer's processor, the CPU, is the brain. It's the mastermind behind all operations, crunching numbers, making decisions, and telling every other component what to do. But even the smartest brain needs a place to store information and retrieve it quickly. Imagine trying to solve complex problems without a notepad to jot down your thoughts. That's where memory comes in. It's the brain's super-fast notepad, holding all the data and instructions the CPU needs to keep things running smoothly. It's like having an assistant that's always ready with the right information at the right time. Without this quick access storage, your CPU would constantly be waiting for data, slowing down your entire system. Memory ensures that everything you do on your computer happens seamlessly. Without enough memory, your computer would be like trying to work with a brain fog. Tasks would become sluggish, and your productivity would plummet. Applications would take forever to load, multitasking would be a distant dream, and good luck trying to edit that 4K video. You'd be stuck watching that loading icon spin endlessly. So yeah, memory is kind of a big deal. It's the difference between a smooth, efficient experience and a frustrating, laggy one. In this comprehensive guide, we'll explore the ins and outs of computer memory, from the basic building blocks to the latest and greatest technologies. We'll delve into how different types of memory work and why they matter. Get ready to unlock the secrets of this essential component and learn how to keep your computer running at peak performance. Whether you're a casual user or a hardcore gamer, understanding memory can help you make better decisions and get the most out of your machine.
Your computer's short-term memory. What is RAM? So let's talk about the MVP of computer memory, RAM, also known as random access memory. RAM is a crucial component in your computer that plays a significant role in its performance and speed. Imagine RAM as your computer's mental workspace. It's like a desk where you can quickly access all the tools and documents you need to get your work done efficiently. When you open a program, load a file, or even type a sentence, all that data gets temporarily stored in RAM for lightning-fast access. This temporary storage allows your computer to handle multiple tasks simultaneously without slowing down. The beauty of RAM is its speed. Unlike your hard drive or SSD, which are designed for long-term storage, RAM is built for speed and efficiency. It allows your CPU to retrieve information almost instantaneously, which is crucial for keeping your computer responsive and snappy. The faster the RAM, the quicker your CPU can access the data it needs to perform tasks. Think about it. Every time you click a button, open a menu, or scroll through a web page, your CPU needs to access data in milliseconds. This rapid access is what makes your computer feel fast and responsive. Without RAM, these simple tasks would feel like an eternity. Imagine trying to work on a computer that takes several seconds to respond to each click. It would be incredibly frustrating. But here's the catch. RAM is volatile memory. This means it only holds information while your computer is powered on. Once the power is turned off, all the data stored in RAM is lost. That means it only holds information while your computer is powered on. As soon as you hit that power button, poof, everything stored in a RAM disappears. As soon as you hit that power button, poof, everything stored in RAM disappears. This is why it's essential to save your work frequently to avoid losing important data. That's why saving your work regularly is so important. You don't want to lose those precious cat memes, do you? Regularly saving your work ensures that even if your computer shuts down unexpectedly, your data remains safe. In a nutshell, RAM is the temporary but essential memory that keeps your computer running smoothly and efficiently. It allows your computer to handle multiple tasks at once and ensures that your system remains responsive. It's the unsung hero behind your seamless computing experience. Without RAM, your computer would struggle to perform even the simplest tasks, making it an indispensable part of modern computing.
Bits and bytes, the language of memory. Now, let's get down to the nitty-gritty of how memory actually works. Memory is an essential component of any computer system And understanding its language is key to grasping how computers store and process information. At its core, computer memory is all about storing information in the form of bits. These bits are the smallest unit of data in a computer and are fundamental to its operation. Think of a bit like a tiny switch that can be either on or off, representing 1 or 0. This binary system is the foundation of all digital data. These ones and zeros are the fundamental building blocks of digital data. Every piece of information, whether it's text, images, or videos, is ultimately broken down into these binary digits. But a single bit isn't very useful on its own. It can only represent two states, which is quite limiting for storing complex information. That's where bytes come in. A byte is a group of 8 bits, and it serves as the basic unit of measurement for memory capacity. By combining bits into bytes, we can represent a much wider range of data. A byte is simply a group of 8 bits, and it serves as the basic unit of measurement for memory capacity. This grouping allows for the representation of 256 different values, which is sufficient for encoding a single character. For example, a single character you type on your keyboard, like the letter A, typically requires 1 byte of storage. This is because each character in the ASCII encoding scheme is represented by a unique byte. To handle larger chunks of data, we use prefixes like kilobytes, megabytes, gigabytes, and terabytes. These prefixes help us quantify and manage the vast amounts of data that modern computers need to process. Each prefix represents a 1,000-fold increase in storage capacity. For instance, 1 kilobyte is 1,024 bytes, 1 megabyte is 1,024 kilobytes, and so on. This exponential growth allows us to handle increasingly larger datasets. For instance, 1 gigabyte is equivalent to 1,024 megabytes, and 1 terabyte equals 1,024 gigabytes. This hierarchical structure makes it easier to understand and manage data storage. Understanding bits and bytes is crucial for grasping how memory capacity is measured and how much data your computer can handle at once. This knowledge is fundamental for anyone working with computers, whether you're a technician, a programmer, or just a casual user. It's the foundation for understanding the different types of memory and their capabilities. From RAM, which provides quick access to data for running applications, to hard drives and SSDs, which offer long-term storage, each type of memory plays a crucial role in the overall performance of a computer system. By understanding the language of memory, you can make more informed decisions about your computer's hardware and optimize its performance for your specific needs. Whether you're upgrading your RAM for better multitasking or choosing a larger SSD for more storage space, knowing how memory works will help you get the most out of your technology. So, the next time you think about your computer's memory, remember that it's all about bits and bytes working together to store and process the information you rely on every day. This intricate dance of ones and zeros is what makes modern computing possible, enabling everything from simple text documents to complex video games and beyond. In the grand scheme of things, understanding the language of memory is just the beginning. As technology continues to evolve, so too will the ways we store and manage data, pushing the boundaries of what's possible in the digital age.
RAM versus a ROM, permanent versus temporary storage. We've already covered RAM, the workhorse of your computer's memory system, but there's another type of memory you should know about, ROM or read-only memory. Unlike RAM, ROM is non-volatile, meaning it retains its stored data even when the power is off. A ROM is like your computer's instruction manual. It contains the essential programs and data needed to boot up your computer and perform basic functions. This includes the BIOS, which acts as the intermediary between your computer's hardware and software. While you can read from ROM, you can't write to it like you can with RAM. The data stored in ROM is permanent and unchangeable, ensuring your computer always has access to the critical information it needs to function properly. Think of it this way. RAM is like your computer's short-term memory, while ROM is its long-term memory. RAM handles the dynamic, ever-changing data your computer needs for everyday tasks, while ROM stores the permanent instructions that keep things running smoothly.
The need for speed, DDR and beyond. As technology advances, so does the demand for faster and more efficient memory. That's where DDR, or double data rate memory, comes in. DDR memory is a type of RAM that offers significantly faster data transfer rates compared to its predecessors. Over the years, we've seen several generations of DDR memory, each offering improved performance and efficiency. DDR2, DDR3, and DDR4 are the most common types found in modern computers. Each generation boasts faster speeds, lower power consumption, and other enhancements. The latest and greatest is DDR5, which takes things to a whole new level. With even faster speeds and increased bandwidth, DDR5 is paving the way for even more demanding applications and smoother multitasking. But speed isn't everything. There's also cache memory, a small but mighty type of memory that sits between the CPU and RAM. Cache memory stores frequently accessed data and instructions, allowing the CPU to retrieve them even faster than from RAM. Think of it like your CPU's personal cheat sheet. The world of memory is all about pushing the limits of speed and efficiency to keep up with the ever-increasing demands of modern computing.